We are having Open House 2014 and this is the last session that we are having, the Smart session on Rosenberger. Before getting into the Smart session, let me give you a small insight about Rosenberger. We are working with this company. It's a company from Germany. We are affiliated and associated with this company since 2010. We have done quite a few landmark projects with this company, and these projects are all state of art. So you will be coming across quite a few instances that we are having in the recent past and also remarkable achievement elsewhere. So before getting into the presentation, we are having a very important delegate with us. He is Mr. Julian Kauke from Embassy of the Federal Republic of Germany. Mr. Julian Kauke is appointed for Development Cooperation, Commercial and Trade Selection. I would like to invite Mr. Julian Kauke to grace the occasion. Thank you.
Thank you very much, Ezan. Dear representatives from Rosenberger Company and the Ambra Company, dear ladies and gentlemen, thank you very much for giving me this opportunity to talk here. I feel very much privileged to have the honor to talk on this occasion. And on behalf of the German Embassy, I would like to thank all of you for giving me this opportunity. For me, this is not only attending a ceremony, but also a rather special occasion. This business gathering is another indication of the long-lasting, friendly economic relationships between Bangladesh and Germany. Or in this specific case, between German electric equipment producers and Bangladeshi businessmen. We feel proud to know that Rosenberger has its own office here in Dhaka. Bangladesh is one of the fastest growing IT and telecom markets in Asia, or rather the whole world. Such rapid growth often results in the use of lower quality standards. For this reason, I'm even happier to see that the Bangladesh market has developed a certain level where consumers are quality conscious and now firmly depending on high quality items from professional outputs to compete in the market. And I'm certain that Rosenberger can meet this high quality demand. For more than 50 years, the name Rosenberger has been synonymous with top quality products for different aspects of the high-frequency technology. The company was founded in 1958, so over 50 years ago, and started with a small family-run metal workshop in Bavaria. Now it has developed globally into one of the leading manufacturers of connectivity solutions in high-frequency and fiber optic technology. To my knowledge, Rosenberger has more than 5,000 employees worldwide, as well as factories located in China, India, and several other countries all around the world. I am convinced that Rosenberger Asia Pacific has the ability to provide a broad range of products to address the needs of the customers in Bangladesh. We are very glad to know that Rosenberger is present here in Bangladesh. Now, to conclude my short speech, I would like to underline that Germany is the second largest trading partner of Bangladesh worldwide. German products are always associated with the highest quality. We are convinced that the presence of German high technical quality products in Bangladesh provided by Rosenberger will lead to further increase in the bilateral trade between Germany and Bangladesh. And I wish Rosenberger every business success of the future here in Bangladesh, and would like to hand over now to Mr. Lawrence Miao, who is representative from Rosenberger office in Shanghai. Thank you very much.
Thank you, Julian. Thank you, Esan. Thank you so much. So the major topic for today is big data and data center transformations. However, before I go into this major presentation, I want to talk a little bit more about myself as well as the company here. I'm from Shanghai, China. Why we are coming from China? Because we are the head office of Rosenberg in Asia Pacific. That's why we are from Shanghai. So as I said before, I talk the major topic. I want to give you a little bit more information about the Rosenberg company. As Julia already mentioned, Rosenberg is a Germany-based company in Bavaria. The company was founded in 1958. We have a 56 years old history now. And the company is still family-owned and is currently managed by 3 sons who act as a CEO, CTO, and CEO. All of these brothers now are around 60, over 60 years old actually. Our global headquarters is located in south of Germany in Bavaria, which is close to Austria. This is a picture of our global headquarters office, including R&D centers. In terms of business distribution, we are having about 27% sales revenue from this region, including Bangladesh. That we have been working with like Telenor, Banglalink, and Grameen for over 10 years here, which is for telecommunication products. Then we Germany, the country itself, we are having about 20% income of global revenue. The rest of Europe generates about 26% of total revenue. And in Americas, including South America and North America, we're having about 1/4 of total income. The major technology and the focus for Rosenberg is on RF radio frequency and fiber optics technology. So based upon that, we are actually focused on 6 business areas or 6 business segments. First is for communications. We are working with Nokia, Huawei, and Ericsson, these kind of manufacturers for over 30 years. For wireless solution, we work with many carriers, operators for providing the total site solutions for 3G, 4G. And for automotive, we are working with many car manufacturers, including BMW, Mercedes-Benz, and many other car manufacturers for supplying the cables, connectivity products. Then for medicals, we work with many equipment manufacturers for supplying this kind of a cable assembly inside the medical equipment, including CT, MRI, and PET CT. Then we do have our enterprise data center cabling solutions that we are going to focus on today. Last but not least, we also supply many products to test and measurement industry, which are in fact, even we are calling test measurement, which is actually for military. So we supply many products to the military industry, including for missiles or other weapons. Besides our global headquarters in Germany, we have our Asia Pacific headquarters in China. So globally, we have 12 R&D centers across the world. A few are in Europe, some 2 R&D centers in China, and 3 R&D centers in the United States. We have a total 18 manufacturing plants worldwide, including 4 in China and 1 in India. Then in almost each region or many countries, we have our local sales office, including Bangladesh. Here we have our local sales office. Mr. Dulav is the head of the sales office, and he has a few staff with him. So as I said, we have in this region we have many sales offices that I don't want to read about one by one, but almost each country we have our sales office. Our major customers, as I already mentioned a little bit, we work with many OEM equipment manufacturers for supplying the products. For Anderson, Ericsson, we have been working with them over 30 years. For Huawei, since they started their operation, we started to supply our products to them. For Samsung, Samsung has a new business unit with network solutions that we Rosenberg have been one of the major suppliers to them. Definitely other customers, including ZTE, Actel, Lucent, etc. Then I already mentioned that we also work with many operators, including Telenor, Grameenphone, Banglalink here for many over 10 years. Then definitely many other operators in this region are our customers. Particularly for enterprise IT data center cabling industry, we have been supplying products to many global customers, including T-Mobile, T-Systems in Europe, in States, under the Chinese operators, South America operator level 3, and many banks from Germany, originally Deutsche Bank, and Royal Bank of Scotland Group, and many local Chinese banks as well. In addition to that, today is a big data center day. So we work with many internet companies, including like Google or WeChat. Some people are using WeChat with the Tencent and other internet companies for supplying our data center cabling products. For instance, Alibaba was just listed in Nasdaq in the States, which is the #1, biggest internet company. So we are one of the major suppliers to Alibaba for many years. So many other customers, including the Frankfurt Airport, Munich Airport, are having our customers for years. So this is a brief introduction of our company. After that, I can get to the major presentation of today, which is to talk about big data center and data center transformations. Some of you already visited our booth upstairs. We have showing some of our products, including the traditional premise cabling products for telephone or for data transmission. And we also are showing a Pyxis intelligent management system, which can be used for both premise cabling and data center cabling. But here, I'm not going to talk about any particular products. I want to talk about some of the big data development trends and the recommendations how we should build up a data center to support the current market and the customer needs, such as the big data center exchanges. So again, I'm going to talk about the trends and the recommendations, which probably can be helpful for you in your daily works or your future works. So the topics I'm going to talk about, including 4 bullets. First, let's see what and how the big data center is currently developing, and how we can support the big data center, or how we can make the data center possible. What kind of data center would be able to support the big data center, and what kind of technology can support this kind of data center, which is we call virtualized cloud computing technology, enables data center which is able to make big data center available for everybody. So that's the first topic. Secondly, I'm going to talk about the architecture of the data center. Many of you probably already working on data centers. Some are installers, some are designers, some are engineers. You know there are a few architectures that can support a data center. So I'm going to talk about the advantages and of TOS architecture and EOR architecture. So this could be for your reference or for your, I think for your reference in your works. Yeah, build up a data center in that way. We have to kind of new innovative way to build up a data center, which is to use a so-called modular data center. Not say technology, a kind of a way to build up data center. So I'm talking about that. Last but not least, I talk about the latest 40 gigabit and 100 gigabit data center cabling standards and some recommendations which are able to support the above points that I just mentioned. So let's go to big data center. So everybody are talking about big data center. So how that happens and what drives the big data center? It's a big data. So first, everybody is using mobile phones or smartphones today. You are having a lot of applications. You need to download the videos, making calls, sending messages, which is a huge data. So that's one of the factors help bring up or generate big data. The other thing is the Internet of Things. In many countries, they are building up the Internet of Things, which connects the things, the mobile devices, and the entire Internet, which also generates the huge data. Then the triple play network, including TV, broadcasting, telecommunication, Internet, also generates big data. So, but what kind of technology that are able to make this real big data available or be feasible for people to use, which is so-called cloud computing technology. So how cloud computing technology will be available, which is to so-called with the software-defined virtualization technology that I'm going to mention. But before that, let's look at the data. So look at the current big data, or the digital universe and the cloud. Till year 2011, according to research, there are around 1.8 zettabytes data already. So by end of 2020, it is expected the data or the digital universe will have a total data figure something like 35 zettabytes. That's a huge number. That is equal to 10 to the power of 21st bytes. So among these big data, how many are being touched or inside the cloud service? So currently there are about 50% of the big data in the cloud, and by end of 2020, there will be about 1/3 of the total information will be touched or either inside the cloud service, which is about 12 zettabytes inside the total 35 zettabytes. So besides this big data inside the digital universe, let's look at the traffic through the IP network. So according to research, there are about 50% of the current global IP data are generated by the internet companies like Google, Facebook, Twitter, or Tencent, or Alibaba. And others are many from telecommunication companies, including like Banglalink or Grameenphone, and many financing companies like Citibank or many big, huge banks. They need to, because people, anybody taking money or get money into a bank, the data exchanges through the data center. Also from governments. And in 2012, according to research, there are about 50%, over 50% of total data traffic was generated by the internet video. In addition to the global IP data traffic, let's look at the mobile data traffic, because everybody using mobile devices or mobile phones. According to research from Cisco, by end of the year 2018, the total mobile data traffic is expected to increase to 15.9 exabytes, and which is around 11 times of the number of in 2013. And look at the right side of the picture. There are about 96% of the traffic are generated by the smart devices or non-smart devices. All these traffic data are called smart traffic. So we know that huge data is in the digital universe, in the cloud, and there are more and more IP data, and the mobile data are being generated. So the booming of this kind of huge data or big data and data traffic requires much more intelligent networks, which with very high or much faster and high bandwidth, and also the huge data centers, which must be equipped with cloud computing and service capabilities. So let's see how we can make that possible. The current or latest development is to use a software-defined virtualization technology that will be briefed in next few slides. This kind of technology will be able to support or make it possible of the data center and digital universe formalization. So virtualization is a kind of a technology, supports the cloud computing is a technology or concept, make the big data center, big data formalization available. So let's see what's called a virtualization technology. So we can see left side of the picture, which is a traditional network setup. There are a few servers with a few applications installed on each server. However, the latest virtualizing technology enables more applications on any single server. In the past, let's see, on each server there are 3 applications. Now, the virtualizing technology can help us to make it, the other server can be running, like 4 applications or 5 applications. That's called a defined virtualization. By having this kind of technology, much more data traffic can be transmitted through the network, and this kind of data traffic capacity can be even double or even more times of the traditional network. Let's see how that virtualization technology works. So any application can be shifted or moved into the other servers as required, which is unlike the usual or the current or the past network. And when some server is powered down, the application running on that server can be automatically shifted to other server. When the power is up again, the applications can be automatically moved back to the server. So this is called kind of virtualization technology. I try to make this simple, help to understand. Even there are a lot of deeper knowledges or technology we need to learn, but this is make it simple how or what the virtualization technology looks like. So now let's look at Ethernet itself. We talk about servers, so now we need to get in touch with Ethernet. According to research of IEEE 802.3 in 2011, in 2014 this year, most of Ethernet network is running on 10 gigabit. But if you look at the number or the figure in 2020, most of the Ethernet network will be running at 40 gigabit, with some running 100 gigabit. There will be almost no 100 megabytes or 1 gig network anymore in the future. I think many people are familiar with the very traditional design of the data center architecture. There will be core network, aggregation switches, and access switches. Those core switches, aggregation switches are running at 10 gigabit or 40 gigabit, and gets to the access switch, which connects with the server, will be running at 1 gigabit. So how does a server, if there's a server at the leftmost side, connect with the leftmost access switch, the data will be going through this access switch to the aggregation switch, to the core switch, and gets to this switch, gets to this access switch, then gets to the server, which just takes too long paths to go through and causes much more latency while and using more bandwidth of networks. But however, again, this is very traditional that we have been using for years. We still can use that if you think it's sufficient for your architecture, or we call fabric data center architecture. Different from the traditional data center architecture, inside the core network, there will be spine and leaf switches to be put together to set up a so-called core network. And each leaf switch is linked with each spine switches. So that you can imagine, according to previous slides, that can make the virtualization possible and make the transmission path the shortest and use the length of the bandwidth. So from that core switch, we use the OM3 or OM4 fiber optic cable to connect with the access switch, which is transmitting the 40 gigabit and 100 gigabit bandwidth. And from the access switch, definitely connects with the traditional servers. So this is the latest development that is able to use virtualization technology and supports the cloud computing. So in other view, it looks like that. So the core switch or the core network, including the spine and the leaf switches, they can be, if you look at the slides, there will be access switch here, but sometimes some customers, they want to connect their servers with the leaf switch directly, which is also possible. That depends on the real demand of the applications. So in summary, there is an international standard TI 942 published recently to accommodate or to get all this what I just talked into a global international standard. So this is Global International Standard for building up the so-called fabric architecture data center supports the cloud computing data center by using virtualization technology. Okay, after talk about big data trends and the virtualization technology, let's look at the real architecture or the structure of the data center. How we put the racks and how we put the equipment inside the data center. We always talk about EOR. EOR stands for end of rack, which means you put your access switch at the end of the rack row. Then all of your servers are connected to that access switch on same row. So that's called end of rack. Again, the access switch has put end of the row or head of the row, depends how you call the head and end of the row. So this has been used or can be used for traditional small-scale data center, which is okay. But this requires very comprehensive and detailed design because you just don't want to waste any ports of the switch. You want to use the lowest cabling cost, use less cables to connect the switch with the servers, and you don't want to have any wasted ports or empty ports live there. And this is suitable for the low and medium density server rack layout scenario. Once you have like cloud computing, a huge racks inside, like 300, 1,000 racks inside data center room, this kind of architecture layout will not be best or suitable. I'm going to talk about in the next slides. And this kind of architecture requires much more copper cabling. But again, due to you have a very detailed, comprehensive planning, all of your switches ports will be fully utilized. So the utilization rate of your switch is very high. And since you are 100% using your ports here, there will be huge cables at the end or at the head of each rack row. So there will be huge cables there which cause difficulties for people to manage the cable at the head or end of the rack. But I just want to talk about pros and cons for you to consider. So in addition to end of rack architecture, there's a top of rack architecture. So what does that mean, top of rack? Which is to put the switches, access switches, and the fiber optic panels on top of each rack. And gets the cable connected with access switch down to the servers directly. There are a lot of advantages that I may talk slightly later, but you can see that's a difference from end of EOR structure. So this will be applicable for the cloud computing data center using the virtualization technology. And it can support a very high density structured cabling because each cable probably supports one rack. The other cable just going down to the servers. Unlike the EOR, there will be huge cable at the same point, end of a rack or head of a rack. And less copper cabling and more fiber optics will be used because it supports much higher bandwidth. And it's modular design and quick deployment, which I'm going to talk, which is micro modular data center. You can actually imagine from this structure, this picture, everything can be built in a module for quick deployment. Then it's very easy to manage cable at the head of the rack rows because there are less cables. So that's the TOR architecture. So by comparing these two, both have pros and cons or advantages. In summary, end of rack structure, the utilization rate of the switch resource is very high, can be used shared for entire rack row. And it's very easy to manage the cable between server and access switches. However, as I said, there will be huge cable at the end of the rack there, which will cause a lot of difficulty. And it is very easy to move or add and change your cables, which connects the server and the switches. Because you usually use a single cable to connect them. You can either remove it or add or change. However, look at the top of rack, there are also some advantages here, which is mostly easy and quick deployment possible, and less LAN cables and and shorter length than the end of a rack structure. And the cabling cost, in fact, will be lower. And when you want to do some upgrade of your current data center, you will spend less cost on upgrading. Lately, I'm talking about upgrading ability lately. And these are preferred in very high density application, such as cloud computing data center. So these are the key advantages of the information I want to share with you that can be your reference. I'm not saying which one is the best, which one is good, which one bad, but both are having advantages. So I already mentioned a little bit about micro modular data center. So micro modular data center, why should we have that? So if we build up a cloud computing data center, that must be very huge. It costs a lot of investment of building up a building and buy the equipment, put the cabling on, a lot of air conditioning system required, lighting system, security system, so it costs a lot of money. And the operation cost for running a cloud computing data center will be also very high, because the cloud computing data center is running 24 hours, 7 days a week. It never lost any down or any stop. So the operation cost, especially the cost spending on air conditioning system or the power consumption is extremely high. And due to the current big data development, you can see every day the data increase dramatically. Everybody using more and more smart applications. And many customers who own the data center, they want the data center to be built in a day. Or in 1 hour. How can be that? So they have kind of a quick deployment demands. Like Google or Twitter, they want to build up a data center within a week. Like Tencent, one of our big customers, who owns the WeChat, they want to build up a data center within 2 weeks. How could that be possible? Which we have to use the micro modular data center concept. And to build up a traditional cloud computing data center, it requires a lot of coordination, integration planning of the IT network with the construction itself. And the site material is the installation of the site installation quality also cannot be assured because the skill of the different installer will be different, right? And also there will be huge material, including network equipment, including server switches, racks, cables, power units. It's a very complicated to manage site material. So that's why the industry or the customer who needs a data center, they want to have kind of a new concept, a new way to build up the data center, which is so-called micro modular data center. So make this standardization of each rack that I'm going to talk, make it modular, make it the products can be manufactured in a factory like Foxconn, which makes iPhones. So everything can be made in Foxconn factory and shipped from Foxconn factory to the site within a day or two. Then the data center cable can be put on within a few hours, then it can be done quickly. That's the driving factors why micro modular data center is required. So the definition of micro data center is like this. It consists of few racks. The rack can be even PDU rack, network equipment rack, or other racks, but they have all the accessories pre-installed and tested in a factory, such as Foxconn or other factories. And each rack module has its own defined function. Some is for power, some is for data transmission, some are for others. They have the same function, but and each same function rack or module have the same input and output interface, which is able for the quick deployment and backup. So if I look at the picture, it works like this. If somebody builds up a module, a rack like this, they put in a room of the data center, and the rack with the switches or patching unit here, and servers are here. This is completed, built in the factory and tested. All cables are connected actually. Here is not showing cable, but actually the modular rack should be with cable here already here. They are fully tested. Once you get the power on and the interface connected, it works. So the quick deployment like that. We buy 100 racks. We ship to there within a day or two. I put it inside of data center room. Then put the major fiber optic trunk cable on top of rack. So in this way, we must use top of rack structure. To use the end of rack will not make it work. So everything I talked are linked. Top of rack, micro data center. Finally, you get to know to use a virtualized top of rack architecture with micro data center, building data center available for supporting the big data. That's the way I do it. So here's a real picture that Rosenberg supported last year. Actually, not last year, 2 years ago, to a global internet company. They use this kind of micro modular data center concept plus TOR architecture for building up their data center. So all data center can be built within a week. Everything are pre-assembled, tested in factory, including Foxconn, Huawei. Huawei also does this. And ship to the data center side, get the main trunk cable plugged in, get the power plugged in, it works. In terms of the cable itself, because Rosenberg is a company manufactures cables and connectivity, so I'll talk a little bit about the cable itself. For instance, it's for 10 gigabit interface of access, which usually there are a few standards or technology make the network workable, including SAP DAC cable, which is direct attached cable, which is used to a Twin-X cable. However, the 10 gigabit supporting length only up to 10 meter or maximum 50 meter. So the current most popular cables for supporting such 10 gig cloud compute data center and able to transmit up to 300 meters, 10 gigabit data to use OM3 or OM5. These are global or international standards defined. And they also cost much less of small power compared to the source. Compared to the copper source. So here's a way to use the RJ45 copper cable, category 6A cable, which can support up 100 meters for the 10 gigabit. This is really not recommended because it consumes much more power. Power is so important. So sometimes people call we need a green data center. From cabling perspective, that means we have to use a fiber optics, which consume much less power and support much longer length of 10 gigabit data transmission. Another thing that we want to recommend is for top of rack solution, and by using the micro data center, micro module data center concept, we have a recommendation to use a kind of a tray mountable patch panel. Usually the panel is mounted on the rack or the cabinet. But for supporting the top of rack and the quick deployment of the modular racks, we have to recommend to use this kind of fiber optics, either or copper, RJ45, the LAN cable category 6 or category 6A or category 7, or the hybrid patching panel. So this can be hybrid. Oh, here's a picture of a hybrid. The copper can come from here, fiber also can come from here. So here it gets to the top of rack. You just plug it on, get power on, and it works. Data center is completed for the building up here. So now, cloud computing. Cloud computing, if we talk about 1 gigabit, 10 gigabit, there's something not for cloud computing, because that's for traditional network requirements. For cloud computing, for supporting such big data, as we talked already, will be 35 zettabytes by end of year 2020. We need to have the network supporting 40 gigabit and 100 gigabit bandwidth. Otherwise, we are not able to make the cloud computing possible, make the virtualization technology work. So now let's get to the 40 gigabit and 100 gigabit. This is a little bit more details, especially for those designers and installers. There are 6 international standards talking about the 40 gigabit and 100 gigabit standards. So this blue covered standards are actually for equipments who makes the server switches for getting the 40 gigabit or 100 gigabit information or data transmitted in short length. But for such as Rosenberg and many other cabling product suppliers who work with many of our customers is to focus on other three standards, which is for much longer transmission distance with 40 gigabit or 100 gigabit transmission bandwidth. So which is here. So we design, develop, we supply products for supporting 100 meters of the 40 gigabit or 100 gigabit transmission, and we supply products for supporting 150 meters of that kind of bandwidth, or we supporting the 40 gigabit and 100 gigabit for up to 10 kilometers by using single mode fiber. So we need to focus on these three standards. So again, look at the back to the slides. To supporting this kind of transmission distance, the only way is to use the fiber optic cable. Use either the OM3 or OM4, and this single mode is usually for the backbone that we would not focus on. So we will focus on OM3 and OM4 that is usually inside a cloud computing data center. So if so this is top of rack structure again. Here probably is the access switch in the main distribution area, and the servers are in the equipment distribution area. So on top of a rack, they are connected by using the OM3 or OM4 fiber optic cable. Okay, these are current most popular applied or used solution worldwide. Whatever suppliers, including our competitors or the major customer, Google, or any big customers, financial company, governments, for their cloud computing data center, almost 99% or 100% probably are using this kind of way to connect their cloud computing data center. And the length of this fiber cable, about 88% are less than 100 meters. But some huge data centers, their distance between the server switch up to 300 meters. That's the maximum, that's the limit of the standard. And to support this 40 gigabit and 100 gigabit transmission, from connectivity perspective, we cannot use any traditional LC connector. Somebody knows LC is a kind of a fiber optic connector, or SC connector, FC connector. It's the name of the connector. So that will not make this kind of a transmission possible. We have to use the so-called MPO connector or MTP connector, which is a multi-fiber connector with maximum 12 fiber or 24 fibers inside a small sized connector. So when we are running a 40 gigabit network for Ethernet, the connectivity must be MPO connector with 12 fibers inside. 4 fibers will be used for transmitting, and the other 5 are used for the receiving. And the rest of 4 are not used actually, not used. Then, according to current standard, if to running 100 gigabit Ethernet network, the same connector is applied. However, 10 of each connector, which is with 12 fiber, will be used for transmitting the signal. Each fiber running at 10 gigabit, 10 times 10, which is equal to 100 gigabit. The other 10 fiber or other connector will be running, will be getting the signal. That's the current standard. However, since we are part of the International Standardization Committee, our colleagues in Germany and many friends from other companies are discussing a new international standard to upgrade from this to still maintain 100 gigabit bandwidth, but to use less fiber. So the new standard properly will be like this. Use totally 4 fibers for transmitting and 4 fibers for receiving. So each fiber will be running at 25 gigabit by. That's the new proposed standard is being discussed in International IEC Committee for the moment. However, these are the existing solutions that I think everybody is using for supporting the 40 gigabit and 100 gigabit network. Besides the fiber optic solution, some people will ask whether if there is a corporate solution available for supporting the 40 gigabit or 100 gigabit Ethernet. Unfortunately, I have to tell you there is no current international standard published yet for supporting 40 gigabit, 100 gigabit, even with length only over 10 meters. That's extremely difficult compared to fiber. So there is no international standard. So from our recommendations for 40 gigabit and 100 gigabit, it is to use the fiber optic cable, which is OM3 and OM4 for supporting the needs. Definitely there will require some pre-examined high density touch panels and high density modules. We didn't bring any samples today. Everything you see on top of the floor is for traditional premise cabling. All the cabling used for data center, especially the high density 40 gigabit or 100 gigabit data will be require much high density, high quality, reliable products to support that. People will not allow any downtime of the data center, which will cause huge loss. So I think I mentioned a little bit how to upgrade the current 10 gigabit Ethernet network to the 40 gigabit or 100 gigabit in future for supporting the cloud computing demands. So usually the current structure looks like this. If the data center is within the OM3 MTP connectivity cables for supporting the current 10 gigabit up to 300 meters distance, how we upgrade from that and to minimize the cost for changing the cabling material. So there's a point I want to mention. From Rosenberg perspective, we always think, not only think about technology, the products, we also think about the customer needs. How to minimize or ask customer to spend less money, not for free, but spend less money for upgrading. So we think about that already in place. So the major cost of this kind of cabling solution for support 10 gigabit. For what? Okay. For coffee break? Yeah. I probably want to just finish this. The major cost from this structure is this so-called trunk cable. This is the most expensive and cost product. And the best way to spend less money but get the network upgrade to 40 gig is to maintain or keep this cable there. Because this could be 300 meters maximum. This is very expensive, maybe a few $1,000s. So we want to keep that. But this kind of patch close module are much cheaper, maybe a few dollars. Maybe. So we want the major cost of the product lives there for the upgradability will be the best. So we think about that, and there's a way to do that. We leave the main trunk there. We change the module with even cheaper adapter plate. This will be even cheaper than the previous module. But we change a little bit more expensive patch code, which use a 12.5 patch code to replace LC connectivity. So this makes the upgrade done, and the network can be supporting 40 gigabit or 100 gigabit from cabling perspective. Definitely, you also have to change your equipment. Right. From our perspective, we want to make sure the customer can spend less money for their upgradability. So that's the way we recommend, and we actually have been doing a lot for supporting our customers. They want to upgrade their current data center for supporting the 40 gigabit or 100 gigabit. And now we are in Germany, in Europe, we are largest supplier on this kind of MTP trunk cable in entire Europe. Globally, we are probably not the largest, but in Europe, we are largest. In Asia Pacific, I think we are top of the 3 suppliers on supplying this product. The other thing is a little bit more technical, especially for those designers. So for supporting this kind of high bandwidth data center cabling, besides to use the MTP connector as mentioned, And to use the traditional channel design, which will be having 6 connect points, the attenuation or the loss of the entire channel link will not support the 40 gigabit or 100 gigabit. This people must be very careful, because many people are familiar with the 6-point structure. So for supporting 40 gigabit, 100 gigabit, we must change to 4 points fiber optic channel. So this is not recommended, and makes it not possible to achieve such high bandwidth. We are recommending our customers to do the channel design like this. So here probably is the server set side switches. In between that, we are recommending to have maximum 4 connection points. Per each point, we have a loss of signal loss, fiber optic loss. Even if it's very low compared to the copper cable, but still some loss. Only by doing this way, the channel design can help to achieve such high bandwidth. This is a little more details, technical, but I want to share with you. This is for your reference. And here is the real test data from Rosenberg product. The specification of international standard TI 942 says the channel loss or attenuation should be less than 1.9 dB. 1.9 dB for 10 gigabit, and 2.66 dB for 40 gigabit. By using traditional 6-point channel would not be possible. Only using 4-point channel is possible. Here's the real data by using Rosenberg product. Our real test data is much lower than the international standard, which means, in other words, the transmission of such high bandwidth signal can be even longer than 300 meters. You can imagine. Of course, the standard defines maximum 300 meters. Here is a real example that we supplied to one of our big customers, that they built up their micro-modular cloud computing data center in 2013, last year. They built up the 40 gigabit, this is the first 40 gigabit data center in China last year. The company name is Baidu, which is equal to Google. It's almost like Google. So they use our 4-point cabling solutions, and the real test data shows the transmission distance up to 300 meters. If we remember, the standard says for 40 gigabit by using OM3 fiber can be maximum up to 100 meters would be enough. The test data shows we are able to support in 300 meters, which is exceeding the international standard. And the standard says attenuation loss of entire link should be less than 1.9. However, as I said, the real test data shows our performance gets to 1.0. That's why we can get to such longer transmission distance. So now, by having this in mind, I think it's time to get at least 10 gigabit, and the current 40 gigabit, which is booming actually worldwide, in North America, in Asia Pacific region here, and the future 100 gigabit. 100 gigabit is still a little bit early, but will be there some years later. As I said, before year 2020, there will be almost 1/3 of our network gets to 100 gigabit. And it's the time to get this Ethernet network and the cloud computing data center ready. I think that's it. Okay, any questions? Fast, short.
Well, the last session for Open House 2014, Rosenberger. Let me give you, because I was there in the presentation, and I have learned many things about the upcoming technology and the cloud that Rosenberger is going to offer. And but before that, what we are having as of now, we, being a partner of Rosenberger, we are facilitating in the passive network, and as well as now we are rebranding the word passive because it has turned to active. We are offering intelligent solution through our partner Rosenberger, and at the same time, let me tell you, there are a few landmarks that we have already achieved. We have successfully delivered the first Cat7 network as of now in Bangladesh through Rosenberger. We are in the verge of delivering the largest hotel, Royal Tulip Sipal, in Bangladesh through Rosenberger. This is fully managed by Rosenberger. Apart from that, we have also done 2010 World Cup and 2020 through Rosenberger passive network in all the stadium. So you probably know that we are the official ISP of BCB, Bangladesh Cricket Control Board, and being the ISP of BCB, we facilitate BCB for Wi-Fi, data communication, and all the services. So our partner is Rosenberger over there. So Rosenberger is not something very new to the market. They are there and they are having quite a big instance in Bangladesh market. Apart from that, they are the company who are having the quality, and you can ask whatever the question based on your current demand of passive network. Over to Lawrence.
There have been no questions. Any questions?
Any question? Any question? Can Cat7 be cheap? Lawrence?
You can decide.
So price is with us always. We are at the buyer end. So Rosenberger is supporting the buyer attitude. So it is not that the Rosenberger product are very pricey. You just decide. The product will be at your doorstep. Just decide. What about fireproof cable? OM3? Fiber optic?
Yeah.
Is it there in Rosenberger?
Yes, I already talked about OM3 fiber optic cables. So we are making huge number of this cable for supporting various customers. It's again, you decide the price.
Yeah, he is leaving price to all of us. So we are the decision maker now.
Because I'm not talking about any particular products. I really want to talk about some technology trends, recommendations for all of you here, so you can decide by yourself. So the main point I want to tell people here: you decide. You make your own decision. That's what I want to talk today.
Actually, I really feel sorry for the person, those who are standing and hearing all the session while standing over there. We apologize from Amra companies. We apologize for the inconvenience because it was beyond our control, because the number of registration that we had in the Rosenberger session is phenomenal. So we must thank you for all of your hard work. But I want to ask one very simple question to all of us. Not all of you, all of us. How many of you have seen a clippering tool? A clippering tool. I'm talking about how RJ45 connector can be connected. How many of you? Used it or seen it? Oh my God! The whole room has seen clippering tool. Trust me. If you use Rosenberger, no need clippering tool. It is self-climpered. So I am reducing one of your headache. We do have clippering tool of our own. You can have it, but it is not required. No longer mandatory. The modular can be self-climpered. So isn't it make your life easier? Yes. We have lots of questions inside us, but we are not asking. Why? He is the man who can make everything different. Even you can ask, can we offer some free of cost units? He's the man.
So I mentioned that we are not developing the technology products. I said that we are trying to thinking how to let our customers spend less money. Let's make money or something free for them. Because, so like you talked about Keystone, we developed our without using any tool. So consequently, you actually don't need any skilled, trained installer to do the installation, which also helps to reduce the cost. So we not only developing the technology, we're trying to think for our customers, make much easy or simple product for our customers to use to let them spend less cost, less money, make their life easy, but still using the most reliable, most highest quality product like Julia already mentioned. We assure that our customer 25 years quality warranty. So any issues happen during 25 years, if it's not caused by the mishandling or misstorage, it will be replaced free. That's something you ask for.
Thank you, Lawrence. But before finishing, I am having one of my friend here who is representing one of the very big TV station. I have seen his data center. We all know pair separator, bisector tape. These are the basic things when you are purchasing cable. If you are using bisector tape, then there will be 2 pair cable in one way and 2 pair cable in other way. But Rosenberger is offering pair separator. Everything is double insulated. To my friend in broadcasting industry, they are spending humongous amount of money for low smoke, low horizon cable. No need to spend that much. Rosenberger is here and their product is world standard. If you look at the world report, they are within 1 and 3. So thank you for everyone's patience. Thank you very much for all of your participation. Those who are standing at the back, we apologize for the inconvenience. Next year we'll be making sure that you are having seating arrangement and it is in much bigger place. We apologize for the inconvenience. Your certificate for the participation will be delivered from the networking floor. We will have a small ceremony over there within the next half an hour time. So let's all move to networking floor. Thank you very much. Thank you very much for all your participation.